Now we shall discuss the chapter 3, classification of elements and periodicity in properties. So in this particular chapter we will discuss about the different attempts that were done by different scientists to classify the elements and the different trend in physical and chemical properties of the elements. So we shall discuss them in detail. Now elements has been like nearly from 37 to 118 we have now different elements. So earlier when the classification of elements started, it was basically to arrange the elements in groups so that the elements which have similar properties belong to same group and the one that have different property are kept in different group. So classification of element means arranging the elements according to its physical and chemical properties. And finally we came up to a periodic table, which is the complete arrangement of all the elements in proper manner. Now, a periodic table is basically the classification of elements in rows and columns. The elements are arranged in such a way that there is a periodic variation, that is, after a regular interval of time, the properties will change in such a manner that the same and the next element which is present will have similar properties. So, this was finally done, but how did we come till modern periodic table? So scientists started to arrange the elements according to the properties of the existing elements. So they started to arrange and classify the elements known at that time, and they started to speculate the properties of the element yet to be discovered. So why do we need to know the properties so that we can arrange the elements? And different attempts have been done by different scientists that can be seen on the screen. So we will start the evolution of periodic table started from 1817 by Daubeney. Johann Daubeney started to arrange the elements. He said that elements are grouped in three. He arranged the elements in group of three called as triads. And the elements selected were such that they are kept in increasing atomic mass, and the middle one will have the mass equal to the average of the first and third. So he grouped elements in group of three, and these are called triads, like sodium, lithium, sodium, potassium, calcium, strontium, barium, chlorine, bromine, and iodine. And the middle element will have the mass as the average of the first and third. In the first case, if you see lithium, sodium, potassium, lithium has a mass 7, potassium 39. So if you take the average, that's 46, and 46 divided by 2 is 23. That is the mass of sodium. So he said that the elements are kept in group of 3, and the middle element will have the mass equal to the average of the first and third. But all the elements known at that time could not be arranged in such group of 3. He could arrange calcium, strontium, barium, chlorine, bromine, and iodine, but not all the elements known at that time. So it failed, and then came up the next approach. So this was the first attempt done by Daubeney to give the arrangement of elements. In 1862, next arrangement was done for elements. So we have in 1862 Chancotois periodic table, in which the elements are arranged in periodic cylindrical form. So it's a cylindrical form of arranging the elements in periodic table, and the elements are placed in cylindrical manner according to its geological properties, not on the physical and chemical properties, but on the geological properties. He classified the elements, but this was not accepted, and it is not being discussed in our NCERT also. So Chancotois periodic table was based on geological data. Then came up was the Newland's law of octave. So next classification of elements was attempted by John Newland in 1865. So John Alexander Newland in 1865 gave Newland's law of octave. Now octave means something related to musical notes. Now this was the first attempt to arrange the elements in increasing atomic mass, and he said that when we arrange the element in increasing atomic mass, the first and the eighth element, will have similar physical and chemical properties. So it's a recurrence of elements, just like a musical note. We have the eighth and the first note in music same, like sa re ga ma pa dha ni sa. The first and the eighth note are same. So that's the Newland law of octave. Here you can see it's lithium, sodium, potassium, which have the same physical and chemical properties. So they exhibit similar properties. So every first and eighth element have similar physical and chemical properties. This is Newland's law of octave. So if I consider Be to be the first element and calcium to be, now here if beryllium is considered to be the first element, second, third, fourth, fifth, sixth, seventh, and magnesium would be the eighth. So beryllium, magnesium will have same properties. Now if I consider magnesium to be the first element, then the eighth is calcium. So these three have similar physical and chemical properties. But this was only till calcium, the accepted one. After that, the arrangement could not be done. So then this was accepted only till calcium, and after calcium the elements could not be arranged. So this failed, and next came was Lothar-Meyer's periodic table. In 1868, he arranged the elements in increasing atomic mass. Specifically, increasing atomic mass was a concept made by Lothar-Meyer from its graphical data which he got by plotting the physical property against atomic mass. And the elements that come in the peaks have similar physical and chemical properties. But till the time he could explain all the properties and arrange in its periodic table, Lothar-Meyer's arrangement was done. It was not been published, and before Lothar-Meyer's, next Dmitri Mendeleev's periodic table has been published. So the gap between Lothar-Meyer and Mendeleev was very short, and the basic arrangement for Lothar-Meyer was atomic mass, and he was the first to tell about the physical and chemical property variation, and he plotted different graph for that, but it was not been accepted. So Lothar-Meyer's periodic table was not considered and given any kind of importance. And then came up was in 1869 Dmitri Mendeleev, a Russian chemist, who explained the periodic table, and he was the first to arrange the element in a tabular form in which we have rows and columns. He gave a law called as Mendeleev periodic law, which states that the physical and chemical properties of elements are periodic function of the atomic weight. So as the atomic weight will change, the physical and chemical properties will also change. And after a regular interval of time, we will have an element having similar physical and chemical properties. And he gave a table known as Mendeleev's periodic table, in which we have group and column. There are 8 groups. Each group has subgroups except the 8th group. And we have series known as periods. So Mendeleev's basis of classification was similarities in empirical formulas, similarity in properties of the elements. So we have empirical formulas of oxide and hydride as same, and that of properties same. He arranged the elements in increasing atomic mass, but elements which are having higher atomic mass had been placed earlier than the others. So iodine has a mass lesser than tellurium. Even then, tellurium is placed before iodine to manage the similarities in physical and chemical properties. Even he left few vacant space in between, so that he knew that the elements would be discovered later on which would have similar properties as that of aluminium, and these were later on named as germanium, gallium, etc. They were earlier called as Eka boron, Eka silicon and Eka aluminium. So the vacant places that has been kept in between Mendeleev periodic table was his knowledge and more hard work that he knew few elements would be discovered later on which can be kept in this particular empty gap. So he left gap in his periodic table and the three elements were later on discovered. So this was the first accepted table called as Mendeleev periodic table. Now we shall see the drawbacks of it. He did not place hydrogen correctly. Isotopes were not given proper place because we talk only about one element, not the others having different mass. We talk only about one hydrogen atom, not about the all isotopes. And placement of elements having greater atomic mass before elements having lower atomic mass. So why elements having low are placed after the higher ones? So basic drawbacks were there. So he did not explain the correct position of hydrogen. Few elements also were not arranged in the proper manner. But next, to overcome the drawback, we came up to next table called as modern periodic table. And modern periodic table, if you talk about, it is an advanced and different version of modern periodic table which depends on atomic number. In 1900, the discoveries of subatomic particles and the properties of elements were done. Isotopes and noble gases were discovered in 1900, and Mendeleev periodic table does not give any position for noble gases. So during that time we did not knew about noble gas, and by the end of 19th century we came to know about all these things, and Henry Moseley conducted few experiments, basically X-ray diffraction, to understand the properties of all the elements known at that time. And he plotted a graph between the frequency and atomic number, and he saw that the frequency was varying according to its atomic number. So he plotted the graph and he came up to know that the frequency was varied according to its atomic number. So once we came up to know about subatomic particle, Henry Moseley started to do X-ray and he gave the term called atomic number, which is equal to the number of protons or number of electron in a neutral atom. So number of proton and number of electron defines atomic number, and Henry Moseley considered atomic number as the base to arrange the elements in the periodic table, not the atomic mass. Till now we had been discussing on atomic mass, but it's not atomic mass that we need to know, it's atomic number on which the properties of an element depend. For example, if an atom has an atomic number 5 and the other isotope also has atomic number 5 but mass number different, but we talk only about atomic number and we arrange the elements, and he gave a law called as modern periodic law in which elements are arranged according to its atomic number, and it states that the physical and chemical properties of elements are the periodic function of the atomic number. So as the atomic number change, that is the number of electron or proton change, the properties will also change. And this was a Moseley periodic table which was initially given, but then later on it was modified and we have the long form of modern periodic table. Now over here also the position of isotopes that were undiscovered then were not included in his periodic table. The placement of elements having greater atomic mass before the element having low atomic mass could not be explained logically. The placement of hydrogen in periodic table was not determined correctly. These are the anomalies of Mendeleev periodic table. So to overcome these properties, we have now modern periodic table, which depends only on atomic number. So when we talk about atomic number, we do not need to arrange isotopes. So Moseley periodic table, we can see this is a Moseley's periodic table, but Moseley's periodic table depends on atomic number, and he gave The next, long form of periodic table. Periodicity in chemical properties, valence electron configuration and electronic configuration. That forms the basis of the long form of periodic table, which depends on atomic number, not on atomic mass. So long form of periodic table or modern periodic table arranges the element in increasing atomic number, and it states that the properties will change with the change in the number of electrons. And in this periodic table we have 18 groups that are vertical columns and 7 horizontal rows, which are called as periods. So we have 7 periods and 18 groups. 2 rows are placed separately at the bottom, which are called lanthanides and actinoids. So horizontal rows are called periods and vertical columns are called as groups. And we have 7 periods and 18 group in modern periodic table. Now each period has a fixed number of elements and each group has similar electronic configuration. So when we move in group and column, we have similarity in such a manner that the properties variation can be explained. Now the first period have 2 elements, second period have 8 and third also 8. Fourth and fifth period have 18 each. Sixth and seventh have 32 each. 18 in the main and 14 at the bottom of the row in lanthanoids. So in sixth period, if you see, you will find 18 elements in the normal table and 14 elements which are placed at the bottom. Sixth have lanthanoids in it, so 14 elements of lanthanoid and 18 you will have 32. Seventh period 18 elements in the main block and 14 at the actinoid series, so again 32. So these are the longest form of the periodic rows. The rows which are longest, the period which are longest in the modern periodic table are lanthanides and actinoid, having 32 elements each. The 18 group are numbered from 1 to 18. So there are 18 group and they start from 1 to 18. 1 from extreme left and 18 at the extreme right. So this is the arrangement of element in modern periodic table. Now the electronic configuration of second members are lithium. From lithium to neon, you can see they have only 2 shells. Second period means only 2 shells. So from left to right, the atomic number increases. Lithium and beryllium are more metallic, and on the right side the metallic character will decrease. So the variation results we are talking, and that depends on electronic configuration. You take any group and the members of that group will have similar electronic configuration, and when the electronic configuration is similar, the properties will also be similar. That we will discuss in detail.